Hi again, Summer Academy. It is great to be back with you once again. Over the last couple of days, you guys have been talking a lot about graphical analysis. So using the derivatives of a function to get information about where that function is increasing and decreasing, where it has relative maxima and minima, where it is concave up, where it is concave down, all of this good stuff. And we are going to bring it all together today and look at a couple problems that involve graphs of derivatives. This is a topic that comes up a lot in AP Calculus as well as in college calc classes. So I'm really excited to get into it with you. Let me share my screen and let's get started. All right, let's take a look at example number 1. I have a little sketch of the graph that is in your notes. So this graph shows us the graph of f prime, which is the derivative of some function f. We don't know exactly what f is. We're just given information about f prime in the form of this graph. So we're going to use this graph to identify a couple of things. First, we want to identify the x values at which f has a relative maximum. Now, the way that I like to approach this type of problem is I like to write a little translation statement that takes what the question is asking for and translates it into information that I could find on this graph of f prime. So if I want to know the x values where f has a relative maximum, what would I look for in terms of its derivative? Well, I would have to have a critical point, right, where the first derivative, f prime, is equal to 0. And I know that that's not what I meant to write. F prime is equal to 0. There we go. And then also, I know at a relative maximum of f would look like this, right? It would go increasing to decreasing, which means that its derivative would change from positive to negative. The derivative changes from positive to negative. That's just a little shorthand for that. So I know I want to find a spot where the derivative is 0 and it changes from positive to negative. So let's look at our graph. Well, at x equals 4, the derivative is equal to 0, right? It passes through the x-axis. But at x equals 4, we're changing from negative to positive. So it can't be x equals 4. Let's look at another x-intercept. How about x equals 1? Well, at x equals 1, on the left-hand side, it's negative. Whoops. Sorry about that, technical difficulties. We're looking at x equals positive 1. At x equals positive 1, on the left-hand side, the derivative is negative. On the right-hand side, the derivative is negative. It doesn't change sign. It's negative on both sides. Okay, so that's not going to work. How about this last x-intercept? X equals negative 2. Well, on the left-hand side, we've got positive values. On the right-hand side, we have negative values. Okay, this is looking good. F prime of x is equal to 0 at x equals negative 2, and the derivative changes from positive to negative. Fantastic. So we have it. So f has a relative maximum at x equals negative 2. Awesome. Let's take a look at part B. Now we want to identify the intervals on which f is concave down. Let's write our little translation statement. So if f is concave down, what does that mean in terms of its first derivative? Well, if f is concave down, that means that its first derivative would have to be decreasing. F prime has to be decreasing. So let's take a look at this on our graph. Let's see, we have a decreasing interval from x equals -3 to about x equals -1. So f is concave down on that interval from -3 to -1. Is there anywhere else where it's decreasing? Looks like from +1 to +3. So I'll add that to my answer. Okay, let's look at part C. Now we want to identify the values at which the graph of f has a point of inflection. What does it mean to have a point of inflection? Or a POI for short. We looked at this in our last lesson. To have a point of inflection, the second derivative has to be 0. And it has to change sign. But wait a second. We have a graph of the first derivative, not the second derivative. Okay, so what does it mean for the graph, or what does it mean for f double prime to be 0 in terms of the first derivative, f prime? Well, that would mean that f prime has a horizontal tangent, right? That it has a critical point, that the derivative of the first derivative is 0. So let's look for points where our first derivative is going to have a horizontal tangent. So that would be at about x equals -1, about x equals +1, and x equals +3. Those are the places where the first derivative has a horizontal tangent. That's another way of saying f double prime is equal to 0. F prime has a horizontal tangent. And then what about this piece where f double prime is changing sign? Well, that would mean that our first derivative is changing either from increasing to decreasing or from decreasing to increasing. Sorry, I'm running out of room. F prime is either changing from increasing to decreasing or from decreasing to increasing. So let's see if that's the case at these places where we have a horizontal tangent. Well, at x equals -1, yep, it's decreasing and then increasing. At x equals +1, it's increasing and then decreasing. And at x equals +3, we have decreasing and then increasing. So all three of those x values are going to turn out to be points of inflection. So x equals -1, +1, and +3. Last but not least, we want to identify the intervals on which f is increasing. Well, what does it mean for f to be increasing? That means its first derivative has to be positive. Right? If you have positive slope, you're increasing. That means your first derivative is positive. So we have to look for intervals where this first derivative is positive, where it is above the x-axis. So that would be from x equals -3 to x equals -2. This part is all above the x-axis. It would also be from x equals +4 to x equals +5. At both of those intervals, our graph of f prime is above the x-axis. So f is increasing on -3 to -2, and also +4 to +5. Great. You guys can pause the video here and try practice set A. Remember to write these translation statements where you're taking what the question is asking you for and translating it into what you should look for on the graph of f prime. That's going to be your key skill to mastering this kind of problem. Okay, welcome back. Let's take a look at example number 2. So like I mentioned at the beginning of this video, graphical analysis is a topic that comes up all the time in AP Calculus. And you actually already know enough to complete this AP level multiple choice question. So let's take a look at it all together. Similarly to example number 1 and the examples you've seen in the practice set, we're given a graph of f prime, the derivative of some function f. We want to know which of the following statements must be true. So let's check each individual statement. First, f has a relative minimum at x equals -3. Let's write our translation statement. F has a relative minimum. What does that mean we should look for on our graph of f prime? Well, if f has a relative minimum, that means f prime is equal to 0. It crosses the x-axis. In fact, we can say that f prime of -3 is equal to 0 because that's the x value we want to know about. And also, it has to change from negative to positive. It must go, the function f must go from decreasing to increasing for that to be a relative minimum. So our derivative needs to go from negative to positive. F prime must change from negative to positive. Well, is that the case on our graph? Let's look at f prime of -3. Okay, it crosses the x-axis. It's negative on the left-hand side. It's positive on the right-hand side. So yeah, number 1 is true. F would have a relative minimum at x equals -3. Awesome. So let's take a look at statement number 2, which says the graph of f has a point of inflection at x equals -2. Well, what would it mean for the graph of f to have a point of inflection? Well, we would have to have a horizontal tangent at that point, right? We saw this in example number 1. We would have to have a horizontal tangent on f prime. And f prime would have to change from increasing to decreasing or decreasing to increasing. Okay, let's see if that's the case. Let's go to x equals -2. Okay, at x equals -2, I would have a horizontal tangent. The slope at that point would in fact be 0. But on the left-hand side of this point, the graph is increasing. And on the right-hand side of this point, x equals -2, the graph is still increasing. So the concavity wouldn't actually change. This entire time going through that point, our graph of f would be concave up. So point 2 is not true because we haven't fulfilled this second point. F prime does not change from increasing to decreasing or decreasing to increasing. Let's look at statement number 3. The graph of f is concave down for it 0 is less than x is less than 4. So for x between 0 and 4. So let's write our translation. If f is concave down, what does that mean on our graph of f prime? Well, that would mean that f prime is decreasing. In other words, f double prime is negative. All right, we're putting it all together. So let's find out. Is the graph of f decreasing for x between 0 and 4? Okay, so from x equals 0 all the way to x equals 4. Yeah, it's decreasing that whole time. Statement 3 is true. So both statements 1 and 3 are accurate. So our best answer choice is E. All right. And that is about as complicated as this type of question is going to get. You guys are going to crush practice set B. I know it. Bringing together all of that knowledge of calculus that we have accumulated over the last couple of days. Go ahead and give it a try. I know you're going to do amazing.